Hello and welcome. Today we're doing a question from LeetCode. This is from Blind75 and it's called longest consecutive sequence. It's a medium. We're going to jump right into it. Given an unsorted array of integers nums, return the length of the longest consecutive elements sequence. You must write an algorithm that runs in O of n time. So example 1, our input is 100, 4, 200, 132. The longest consecutive sequence here is of size 4, right? That comes from 1, 2, 3, 4. 100 has just a size of 1, and 200 also just has a size of 1. Example 2, this is our input here. So the longest consecutive sequence would be from 0 to 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8. So there are 9 numbers in here total. The duplicates of 0 here don't really matter. It's just going to result in the same length of the maximum consecutive sequence of size 9. So how are we going to solve this in linear time? Pause the video right now for just 5 seconds and try to come up with how you would want to do it. So if we didn't want to do it in linear time, what's one way to approach this? We could obviously, if we're taking example 1 over here, sort our input array. So this would be an n log n time, but once it's sorted, we know where the beginning of our consecutive sequences would be, and we could just count up. So going from 1, 2, 3, 4, we would find a size of 4, then from 100 it would be size 1, and 200 it would be size 1. Now the time complexity for this would be n log n because we are sorting our input. And for space, assuming this is being sorted in place, we're not really using any extra space, so space is going to be O of 1. Now we know we want to do it in linear time, and there's always usually this trade-off, right, between time and space. So we could be getting better in time, but we would need to be using more space. What if we could do the same exact thing we did over here, start at the beginning of our consecutive sequence, and just start counting up without sorting? How would we do this? All we need to do is keep track of a set. So if we added our input nums into a set, this means now we have a constant time lookup. So we could be looping through our nums, right? Say we start at 100. We want to see if we are at the beginning of our sequence, and only then do we want to start counting. How do we know if we are at the beginning? Well, we just want to see if the number before us exists. If it doesn't, that means we're at the beginning. So over here, does 99 exist in our set? It does not. So we can start counting from 100. At 100, we have a size of 1 for our sequence, but since 101 doesn't exist, our size is 1. Now we go on to our next number, say it is 4. Now we just need to check if 4 minus 1, or 3, exists in our set. It does. That means 4 is not going to be the beginning of our sequence. It's somewhere in the middle, right? The beginning could be 3 or it could be something else. We don't know yet. So we're not going to count just yet. Once we get to 200, 199 doesn't exist. So we can start counting. 200 is size 1. There is no 201, so we are capped at size 1. And so our max length right now is still 1. Now we go on to the next number. We have a 1. There is no 0, so 1 would be the start of a sequence. Now we want to see how high that sequence can go to. So does 2 exist? 2 does exist. So now our size is 2. So current length is size 2. We want to see if we can continue pushing out. Does 3 exist? 3 also exists. So our current length is 3. Does 4 exist? 4 also exists. So current length is now 4, but 5 doesn't exist, so we need to stop. And now we can actually go ahead and update our max length to be this size of 4, which is exactly what we were expecting. So this is all we really need to do, right? This is just going to be a linear scan. We're going to go through all of our numbers, add it to a set, and then go through it one more time, just iterating through, finding if we are the beginning of a sequence. If so, just start counting. So let's go ahead and code this up. The first thing we want to do is have a set. So nums set is just going to be the set of our input nums. Now we also want to keep track of our max length. So let's initialize that to 0. All we need to do now is just loop through. So for number in nums, we want to check if we are the beginning of a sequence. So if num minus 1 not in our set, so not in nums set, only then do we start counting. So in order to start counting, we're going to say our current number is going to be the number we are on, and our current length is going to be 1. It's going to be this number that we are on. Now we just want to see if the next number exists. So while current num plus 1 in nums of set, so say we are at number 1, right, over here, num minus 1, so 0 does not exist in our set, so we are the beginning of a sequence. Our current num will now be 1, or current length will now be 1. We want to see if 2 exists in nums of set. If it does, we can increase current length by 1. So current length plus equals 1, and we're going to reset what our current number would be. So current num plus equals 1. So now it would be 2, and we go back in this while loop. We now check for 3 if that's in our num set. And we keep going in here up until there are still numbers that are just 1 above us. Once we break out of this while loop, we can update our max length. So max length will be the max of what we have so far in max length and what our newly calculated current length is. So current length. In the end, all we need to do is return our max length. So let's go ahead and submit this. Oh, and actually, we don't even need to be looping through nums. We can just be looping through nums set directly. Let's go ahead and submit this. And it is accepted. Now talking about space and time complexity, again for space, we are keeping a set of all the numbers we have in num. So this is going to be O of n if there are n elements in our input. And for time, we are making 2 passes of our input array. First to add it to our nums set, and then because we are looping through our set and keeping counts of our sequences. So we are going through every number twice, which means this is O of 2n, but we don't really care about any constants. We can factor that out. So essentially our time complexity is going to be O of n, just like we had wanted. Now, before leaving, let's just do a super quick example to make sure we understand exactly what our code is doing line by line. Say we have the following input nums 325860001. First thing we do is convert it into a set. So num set is going to be 3258601. We don't really care about these duplicates, and adding it to a set will actually get rid of these duplicates, right? It's going to hash to the same thing. So this is our nums of set. And this is why it's actually better to loop through nums of set instead of nums, because there are just less repeat operations we'll be needing to make. So now we initialize our max length, which is going to be 0, and we just loop through all the numbers in num set. The first number we come across is 3, and we make a check. If num minus 1 not in num set. So 3 minus 1 is 2. Only if this is not in num set do we actually go in this if. 2 is in num set, so we don't do anything, and we just go back in our for loop. Now we're at 2, we make the same check. If 1 not in num set, it is in here, so we don't do anything, go back in the loop. We're at 5, so if num minus 1 not in num set, 4 is not in this set, so we can go in this loop. Current num is going to equal num, and current length is going to equal 1. So we have 5 and 1 respectively, while current num plus 1 in num set. So is 6 in our num set? It is. Current length plus 1 and current num plus equals 1. So now our sequence length is at 2, right? We have 5 and we have 6. And now we want to check if there is a 7. So we go back in this while loop, current num plus 1. 7 does not exist in num set, so we can't go in this while loop. We exit out and we update our max length. Max length was 0. Our current length is 2. We can go ahead and make this update. And we go back in our for loop. We're now at 8. We check if 7 not in num set. That's true. 7's not in here. So our current number will be 8. And our length is now reset to 1, right? This is our sequence we've seen so far. We go in this while loop. While current num plus 1 in num set. 9 is not in here, so we can't go in this while loop. We just see if we want to update max length. We can't. 1 is not higher than what we had. We exit, go back in the loop. We're at 6. Nums of 1 is in our set. We can't do anything, going back in the loop. We're now at 0. Negative 1 is not in this set, so we can go in here. So current num is going to be 0. And our length is 1. While current num plus 1 in nums set. 1 is in here, so we are going in here. We're going to increase our current length. It's now going to be 2. Our number is now 1. We go back in the while loop. Current num plus 1, that's 2. Does 2 exist in our set? It does. We can increase our length. Our new number is 2. Going back in this while loop, we would now want to see if 3 exists. It does. Again, we increase our length. And our current number is 3. That means right now we have a sequence length of 4. We have 0, 1, 2, and 3. We want to see if 4 also exists. So we check current num plus 1. 4 is not in here, so we exit and we update max length. So max length is now going to be 4. Going back in this loop, we're now at 1. Num minus 1 is in num set, right? We were just at that. 0 is in our set. We can't do anything. We also can't go back in our for loop. There are no more elements for us to iterate through. So all we do is return our max length, which is 4, which correctly points to the longest consecutive sequence in our input nums. So we just went ahead and solved longest consecutive sequence from blind 75. If you have any questions, let me know down below. I'll answer all of them. If this video was helpful, like, comment, share, and subscribe. It really supports the channel. And as always, I will see you in the next one.